Hello and welcome to Physics Doctor. My name is Dr. Ghanshyam Tejani and let's start chapter number 9, Mechanical Properties of Solid. And the similar content is covered in JEE NEET unit number 7, Properties of Bulk Matter. This is our session number 4 and this is exclusively for bulk modulus. Let us go with that. Now see, let us have one example what is bulk modulus and how it works. You can see there is a volume V, it is shown here, and suppose it is subjected to maybe a compression from each of the side, from all the sides. So what happen? See, in the compressible material, there is a reduction in the volume. It is noticed, and the bulk modulus, it is a connected property with this. So here, when we consider, it is applicable to solid, liquid, and gases. All the cases, it is applicable. So when it is deformed by uniform some pressure from all the direction, and because of that there is a one property we have to consider, that is a bulk modulus. So it is relevant for the solid, liquid, and gases, and it refers to the change in the volume when every part of the body is under the uniform stress, so that shape of the body remain unchanged. What happened? So there is a decrease in the volume that we need to consider in the case of bulk modulus, and it happens with the solid, liquid, and gas. All the three properties are applicable. However, in the metals, or you can say solid, is the effect of bulk modulus, it is very low. But in the case of liquid and gases, or mostly it is in gases, the effect of bulk modulus is always considerable. So how it works? See, the volumetric strain. First, we need to understand what is volumetric strain. We know that strain means what? Change of length to the original length. But when it comes in the volumetric strain, that means here we consider change of volume. Change of volume. There may be a decrease of volume or there may be an increase of volume. So in case of gases, mostly it is seen. So if you compress a balloon, you may consider if you compress balloon from each of the side, then it is subjected to compression and there is a reduction in volume. So volumetric strain is given by change of volume delta V divided by its original volume. So this is volumetric strain. One more definition is there. And the ratio of hydraulic stress. See, hydraulic stress, that means it is pressure from each of the side we are having on this body. We may consider as a hydraulic stress also. The ratio of bulk modulus, you can say ratio of a linear, or you can say hydraulic pressure to the volumetric strain. So bulk modulus, it is defined as the ratio of excess pressure, or we can say a ratio of hydraulic stress to the strain, right? So it is a stress to the strain, and stress we will be considering as a pressure, and change of volume to the original volume. So this is the bulk modulus. Definition you have to remember this both. One is volumetric strain and second is definition for the bulk modulus. Both kind of question may be asked. If it is volumetric strain question is asked, we need to I need to find change of the volume, and if it is bulk modulus asked, then you need to have pressure divided by its a bulk modulus. It's very simple concept it is there, and mostly we see this kind of concept in a gases. Mostly the concept is not largely visible in case of solid and the liquid, but when there is a higher pressure, this can be the case. We need to consider while designing a submarine or maybe other component which are inside the water. So for that we need to consider bulk modulus. And the inverse of bulk modulus symbol is given as a B. Sometime capital K is also used for the bulk modulus. And the inverse of B bulk modulus, it is known as compressibility. That means 1 by B. 1 by B, it is A B is reciprocal of B is what also known as doing the compressibility. What is the compressibility of the part? Let's have an example. NEET 2017, the questions we are here with this. The bulk modulus of a spherical object is B. Say for example, this is a spherical object having some radius r from the center. So it is question is that the bulk modulus of spherical object is B if it is subjected to uniform pressure. So it is having uniform pressure P from all the side, right? So because of that, there is a some increase, sorry, decrease the cross section area. So this question is asked, right? So the fractional decrease in radius, right? So this is original radius is r. What is the decrease in the radius? Fractional decrease in the radius that we need to identify. The question was asked in NEET 2017, and the options are P by B, P by 3P, 3P by B, P by B. What is P? P is a pressure, outside pressure, and the B, it is a bulk modulus. B is a bulk modulus. That's all this. So here we know that we write B is equal to, sometimes we use also K, but in 11, 12 K is not so popular. So B is equal to P divided by delta V by V. Ultimately, we need to just put values here, nothing else. What is volume of sphere? What is volume of sphere? Can you tell me what is volume of sphere? So sphere volume is equal to pi 4 by 3 pi r cube. If you want the volume of sphere, the equation is 4 by 3 pi r cube. You need to remember all the areas as well as volume for each of this shape. So volume is equal to 4 by 3 pi r cube. In the original, we need here delta V, change of the volume is required to put this value. So what we do? We can do differentiation on both the side. We can do differentiation for both the side. So what is differentiation for that? Delta V, 4 by 3, this pi is a constant, and 3 r square delta r. So dV by dr we can take here 4 by 3 pi, this is a constant part, 3 r square, we can remove this 3 also. So we have here value of dV, dV is equal to 4 pi r square dr. What next? What next? What next? Yeah, we have this equation. Why don't we put these values in the equation? Delta V is equal to P by B. We can put value of delta V is equal to 4 pi r cube dr here. And for the B, value of B, value of, not B, value of V, volume. What is volume of sphere? Volume of sphere is here 4 by 3 pi r cube. We can put these values here. We may cancel out this unknown required data and ultimately become 3 dr by r. So what we need? We need a fractional decrease in the radius. That means dr by r we required here. Dr by r, we can take 3 outside on the opposite side. So it become P by 3b. P by 3b. Do we have solution? P by 3b? Yes. D, answer D is our correct answer. It looks difficult, but actually it is not. When you solve this kind of examples, then you will build a confidence on that. Let's have one more. The normal density of metal is rho. Normal density of metal is given as rho, and bulk modulus is given B. Fine. The increase in the density of block of metal when excess pressure is applied, P is applied to it normally on all the sides. So say for example, this is our object, right? And it is subjected to all the side pressure, and because of that, we can say there is a decrease in volume, right? And so here we need to find out its solution. 4 options are given: rho P by B, rho B by P. It is a P by rho B. We need to derive equation ultimately, nothing else, right? So we know that bulk modulus B is equal to P divided by delta V by V, and we can convert this delta V by V is equal to P by B, and delta V is equal to PV by B. Delta V is equal to P by B. Right. So let us assume if M is mass of the block and its density, we can find density rho is equal to M by V. Rho is equal to M divided by V. We know that density is equal to mass divided by volume. Density, if you want to find, that means it is just a ratio of mass to the volume. So due to decrease delta V in its volume, the increase in the density. See, we know that mass, it's a amount of matter it is inside the body. So matter is constant, right? So if we compress any object, whatever mass before compression, it must be equal to after compression also. So total mass remain constant. Total mass remain constant, right? So we can take differentiation of this. Delta rho is equal to mass is not changing. Volume is decreasing, so it become delta V, right? Delta V. So delta V is equal to PV by V. And therefore, rho, delta rho change of this density is equal to M P divided by Vp, because delta V is equal to PV by B. So ultimately, what is our solution? Mass by volume is become density. So rho B divided by P. Rho B divided by P. Rho B divided by P, that is our answer number D. It is not D, but the answer it is B. P is the correct answer. Now we have example number 3. What is mentioned? If a rubber cube is taken 50-meter deep in a lake, say for example this is a lake, and one rubber cube, say this is a rubber cube, if it is in the deep water, inside the water, if it is go in the deep, so what happen? It is subjected to pressure. It is subjected to pressure because of mass of liquid. If a rubber cube is taken 50-meter deep in a lake, its volume reduces by 0.5%. Right? So you can say this is delta V divided by V is equal to 0.5%. The bulk modulus of rubber, so we need to find B is equal to what should be volume. So this is the original object of this rubber cube, and it is when it is immersed inside this, not it is submerged inside the water, then it become some decrease in the volume from each of the side and become delta V by B is equal to 0.5. Very simple. So we know that delta V by V is given 0.5%, that value is given, and we know bulk modulus is equal to pressure divided by delta V by V, right? So it is a linear pressure divided by its volumetric strain. Now, so we know that, see, excess pressure is water in the diff. So we know that because of water mass, it is always subjected to its load, and we can take this pressure is equal to rho gh, right? If you wanted to find energy, we know that mgh we can use, and here it is pressure, so it is always rho g multiplied by height of water. So right from this, suppose this is a block is here, and this is height, density of water that we know what is 1000, it is used. G we know that we can take 10. So 1000 multiplied by 10 multiplied by h, so it become P is equal to 5 multiplied by 10 power 5 Pascal. Put this value here. P is equal to P divided by delta V by V. Put P is equal to 5 multiplied by 10 power 5. This is the pressure generated because of this depth. Divided by delta V by V. So change of the volume is 0.5. You can convert this percentage into normal values. So it become B is equal to 10 power 8. What is the answer? Answer is C. C is 10 power 8 Pascal. That is our correct answer. One more example you can solve by yourself also. IIT JEE 1988 that was asked. So you should pause the video here and we may solve this. What is given? Example number 4. A solid sphere of radius r and made of a material of bulk modulus K is completely immersed in liquid in a cylindrical container. Again, it is immersed in the cylinder. A massless piston of area A floats on the surface of liquid when a mass m placed on the piston to compress the liquid. The fractional change, the radius of sphere delta r by r is given by. So say for example, one cylinder is given here and it is having some kind of plunger and mass is added somewhat here. So because of that, there will be force will be created, the downward direction, and the compression will be generated inside this. The sphere is in this part, so there is a reduction in volume will be there. So we know that bulk modulus K is equal to P divided by delta V by V. That equation we know that, and the pressure generated because of that. So we know that pressure is equal to force divided by its cross sectional area. So pressure is equal to mg by A. Very simple. And we know that as per Pascal's law, intensity of pressure is equal and uniform in all the direction. So Pascal's law, pressure is equal in all the direction as per Pascal's law. We know that. So therefore, it is subjected to pressure P. And if you wanted to have delta V by V solution for that, so we know that V is equal to pi by 4 by 3 pi r cube of the sphere. If we take differentiation for that to get delta V, so delta V by delta R is equal to 4 by 3 pi, and we may cancel out this, so become delta V 4 pi R cube. We can put this value here, delta V by V, so delta V by V is equal to, you can cancel out this 4 pi, you can cancel R also 1, so it become delta V by V is equal to 3 pi by R. Now we have values for P, we have values for D, so can we put value? Yeah, K is equal to mga 3 delta R. If we take decrease in the case of radius, so delta R by R, you can take this in the power is equal to mg by 3 Ka. Mg by 3 Ka, which one is correct? Answer C is the correct answer. Right, so bulk modulus, the questions are sometime in the examination, however, not so popular, but yes, we have to be ready with this. If suppose if this question is there, then you have to know what is bulk modulus for that. Thank you very much for watching Physics Doctor.